Alright, so let's try 5.3 number 2 just for kicks. So we have 5.3 number 2, it's y double prime minus 4y prime plus 5y is 1 plus 5x, I think?
Yeah.
Yeah.
Okay, so, first things first.
Y homogeneous.
Good, go get the homogeneous solution. So y homogeneous double prime minus 4y homogeneous prime plus 5y homogeneous is 0.
Is this the thing where we have a box of things we need to remember?
Yeah.
Okay, cool.
So, oh,
No.
no.
That's 7.
Sorry.
That's variation parameters.
There is a set of things you need to remember, but they are only solve the homogeneous thing and then make a good guess.
Nice.
You could use variation of parameters to solve this. It would work.
Okay.
It would be a lot of extra work for this. So I need to know the homogeneous solution, right? So how do you find homogeneous solutions
Just
for?
U the RT.
Okay. So you have constant coefficients, so you guess u the RT. So you move to r squared minus 4r plus 5 is 0.
Right.
And then you
Yeah.
massage
solve
this.
from 2 plus or minus I.
It's easy, no?
Okay. Cool. Right.
Right.
Then what?
You write out your Y homogeneous thing.
Okay. So you're like, all right. So y homogeneous then is
Constant.
constant 1
E to
E to the
the
2t.
e to the real part times the t
Cosine t.
cosine imaginary part times the t
plus
B.
C2.
plus c2
Same thing.
and then the same thing with a sine instead of a cosine. Oops.
Right, yeah. And really y is just equal to that. What's my p?
Okay, and then yeah, really your y is this thing plus the particular solution, and then you're like, okay, whoa, wait, particular solution?
Right. This is what I was doing.
Yeah, so then you look at the right-hand side. This is, all method of undetermined coefficients is take a look at the right-hand side. Looks like a polynomial, right? First degree?
Yep.
Okay. You're going to take some derivatives of something and get a polynomial of first degree. Probably started out polynomial first degree.
That's what you do. I remember that.
Yeah, all method of undetermined coefficients is this like, whoa, duh, man, you got some stuff that you differentiate and then you add it together and you get a line. Yo, dude, I bet that stuff was a line to start with. So you guess your particular solution is a plus bx. And the times that this gets complicated, like I'm making fun of method of undetermined coefficients because it's not super like sophisticated feeling, but there is a little subtlety, which is you want to check that the thing that you're guessing doesn't happen to match one of the homogeneous bits. In this case, I'm pretty sure that a and bx don't have anything to do with e to the 2t cosine t. Oh crap. What to do? You guys see the thing I did? That was
X's and T's.
yeah, I did this silly thing I always do where I put x's in one and t's in the other. These should all be x's because the right-hand side had
I
x's.
did that.
Why did we learn that? Why did we learn that with
at the end?
T's?
Because we were using
Because it's
like
like
super
parameterized probably.
Yeah, we learned that one with t's because we're thinking springs, right?
So we're thinking.
But I mean, you could
Yeah.
write at the top, T is sometimes equal to
Yeah.
X.
Yeah, you can of course get around
That's what I
this
was doing when we were
by
doing
saying
one.
let x
Done
be
that on my
t.
homework all the time.
I might just do that at the
Let all
top
these
and then
images
just like go.
Star test, like yeah.
Just let and know things that could happen.
Assume these two symbols are the
Yeah, I
same
feel like
throughout.
the method going down would then be wrong. Like, well, that's not true. It's like, what happened here?
Yeah.
Yeah.
Okay, so anyway, you need to check if it was the same. You would need an extra like okay, maybe slap an x on the whole thing, or an x squared on the whole thing. Doesn't happen super often, but if it agreed with one, if you hit one of the homogeneous solutions, then you'd put an x on there. And if x on there still hits the other homogeneous solution, then you'd put another x on there.
So instead of 1 plus 5x, if it was equals e to the x, and that was your yp.
If it was a e to the 2x times cosine x, like
You have to
exactly
it,
match
like,
this.
identical.
It's gotta match this exactly. If it's just an e to the 2x, no problem. If it's just a cosine x, no problem. But if it's an e to the 2x times cosine x, then you got problems.
So, say that down there, that was like a plus bx. And
Yeah, so
you could
hypothetically,
multiply,
if you had gotten a plus bx down here,
and you
right?
could
And this
multiply-
this would have happened when you had r squared is 0, right?
Right.
Right.
Right, you'd have that repeated real solution of 0
Yeah.
for this case.
So,
So if that happened, then up here, instead of guessing, you'd be like, alright, it's like a plus bx because of that. But both of these are covered by that, so I'd throw an x squared on it.
so my question about that is why not just add an x squared term, or here like an x to the third term at the end instead of multiplying the entire thing by x squared?
So if you just add an x squared term at the end, things won't cancel.
Okay.
Things won't stick around through the derivatives. Really what you're doing is you're adding an x squared because that's going to force through the product rule some preservation of the constants.
Okay.
Does the order in which these things match matter?
No.
No.
Also,
Okay.
I have a dumb question.
Okay.
So, since we're
This is
already,
the longest problem ever.
It's a good thing we've gone over.
From here on out,
Yeah, right.
you just take this and you take some derivatives, right? Like that's not going to be hard. What's your deal?
okay, so you said that if it matches one of the homogeneous solutions, then we have a problem. So
Yeah.
how do we know if it matches it? Because I thought that e to the stuff would not necessarily be a sine and cosine thing, but that ends up being true with complex numbers. And
So if it matches once, it's real.
okay, so we're not in complex problem anymore because even though the r is gotcha. Okay. Cool.
Yeah, you definitely won't have complex forcing terms in this course. I'm not aware of an obvious application of that. My guess is that it's pretty unusual.
Okay.
Pretty crazy.
So, let's finish this off. What do I need from here?
0 and
Primes
b,
of
Y prime and y double
and
prime.
then 0,
Okay.
0.
So yp prime is p,
Oh, yeah.
and yp double prime is 0. So take these, put them in your differential equation. Your differential equation becomes 0 minus 4 times b plus 5 times a plus bx.
Equals
Right.
1 plus 5x.
Yeah, it has to be identically, right? 1 plus 5x.
And then you do the thing with the squigglies and the sharp ones.
Yeah. So you need to
Sharp
kind of.
ones?
It's the sharp version of a squiggly.
What is he talking about?
Are you talking
He's,
about an interval?
he's saying you collect like terms. So you have minus 4b plus 5a plus 5bx,
Oh, okay.
right?
I
That's
got
supposed
it.
to be identically 1 plus 5x.
What's sharp about this?
It's when you like underline the person canceled, right? Or no?
Or the things that are similar. That
So
end up
those
being
are the
things.
same. This is the sharp one.
Why are they? Why
No,
are
the sharp ones.
Oh, I see.
Then what are the squigglies?
The non-sharp
Oh,
ones.
Jesus.
So to illustrate what Naish is saying,
Oh my god.
Squiggly.
Which ones are the sharp
How are
ones?
you in physics?
Sharp. Thank you.
So that one's the sharp one and the squiggly one?
Everything in this
No.
lesson
Oh my
is
God.
classified as sharp or not sharp.
so squigglies, and apparently Nai thinks about those as sharp. Whatever. I don't care how you indicate, but somehow indicate that you're comparing like terms on each side, right? So from the squiggly ones, I know that b is 1,
Like sharp and non-sharp.
Right. and from the others, the constant, I have that minus 4 plus 5a is 1,
Right. And
so I think that means a is also 1.
I'd love to see
Oh,
a math
okay.
textbook written by you.
I'm like, what are these equations? Jesus.
Joe,
Just
I think I should
that
teach.
4, yeah.
You guys
Write
good
a
with
math
that?
textbook.
Okay, Then what do you do to finish the problem off?
Plug
Slap them
back
back
Plug
in,
in.
Slap them back in where?
where you
Um,
want
Up
them to
there
be.
and then
Where
add
A's
that
are.
down there.
Where you want them to be.
Okay, so
into your parking field.
y
Yes,
by itself,
no.
right? Ultimately, the
Yes.
answer is c1 e to the 2x cosine x plus c2 e to the 2x sine x,
I got that.
right? That's the homogeneous bit,
Oh, yeah,
plus
Plus one of plus x.
plus 1 plus x,
Yep.
right? Particular solution here at the end, homogeneous bits here. Whole thing added together is the, what do you call that thing?
General solution.
Perfect.
The answer.
General solution,
Minus
also known as the answer. Good?
equals number.
Okay.